Welcome to EDU World Space.
So here we have the problem 23.64. We're going to draw a crystal field energy level diagram and also show the placement of electrons for the following complexes. So part A, we have vanadium Cl6, 3-. So first we want to find the oxidation number of the metal vanadium in this case. So we assume it's X. And we know that the oxidation number for chloride is -1. That is equal to the total oxidation state, which is -3. And we solve for the X equal to +3. So the oxidation number for palladium is +3. So V3 plus will have an electron configuration as Ar3D2. So now we draw the energy level diagram. One, two, this is the 3D orbital. All right, next one is part B. We have FeF6, 3-. In this case, we assume the iron has oxidation state of X, and we know the fluoride has oxidation number of -1, that is equal to -3. So we solve for X, that is equal to +3. So the oxidation number of iron in the complex is 3+. So for iron 3+, the electron configuration would be Ar3D5. So now we draw the energy level diagram for this. We have this is the D5 orbital. There are 5 electrons, 3, 4, and 5. All right, so that is part B. Part C, we have the complex rubidium bipyridine 3, 3+. And this is a low spin complex. All right, so now we first look for the oxidation number on the rubidium. So we know that the bipyridine has a 0 oxidation state. So the total oxidation state of the complex is 3+. So we know the rubidium has a 3+ oxidation state. So for rubidium 3+, the electron configuration would be 4d5. So there are 5 electrons in the 4d orbital. So if we draw the 4d orbital right here, this is a d5. Since it's a low spin complex, it will be preferably pairing at the lower energy level. So 2 pairs and 1 unpaired electrons. Right, that's for the part C. For part D, we have nickel Cl4, 2-, and this is a tetrahedral. All right, so assuming nickel has an oxidation state of X plus 4 times chloride is -1, that is equal to -2. So we solve for the number X is equal to +2. So the oxidation state of nickel in the complex is +2. So nickel 2+ will have the electron configuration as Ar3D8. All right, since it's a tetrahedral and the configuration will look a little different from before, and the energy is reversed. So we have 2 orbitals at the lower state, and we'll start filling with 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So there are 3 pairs electron and 2 unpaired electrons. That is the part D. So this is the D8 tetrahedral orbital. All right, now look at part E. We have the complex PTBr6, 2 minus. So assuming the platinum has an oxidation number of X plus 6 times bromide is -1 equal to -2. So solving for the number of X, we get a number of +4. So the platinum in this complex will have a charge of +4. So PT4 plus will have electron configuration as Xe 4F14 5D6. So if we draw the electron, so now if we draw the energy level diagram, we will have 2 orbitals on the top, 3 right here. So we have 5 electrons, 1, 2, 3, 4, 5, and 6. So this will be the D6 high spin orbital looks like. All right, next one is question F. We have titanium En 3, 2 plus. So we know the oxidation number of the ligand En is 0. So the titanium will have an oxidation number of +2. So for titanium 2 plus, the electron configuration is argon 3D2, and we will draw the energy level with 2 electrons on the lower energy level, that is the D2. So that is the answer for part F.